Okay, we shall see here. So first what happens? Formation of a volatile complex. Which is the volatile complex form? Nickel tetracarbonyl is the volatile complex formed here. Now next step is decomposition of volatile complex. Now what do we do here? Decomposition of volatile complex here. The complex is taken, the tetracarbonyl complex that is formed, tetracarbonyl nickel complex is heated, subjected to heating at around 450 to 470 Kelvin, a high temperature, where it decomposes. Now the bonds are broken and they decomposes. How does it decompose? Into nickel and 4 moles of carbon monoxide. Now this nickel which we get will be in its pure form. Pure metal we get out. Is it clear? So to write the equation, it's very easy. Just see here, nickel tetracarbonyl, you know, tetra means 4 carbonyl. CO is called as carbonyl when it is taken as ligand. You will study what is ligand. This comes in coordination compound chapter. So here tetracarbonyl nickel means 4. So say Ni plus 4CO. You get same NiCO4. Next, exact reverse of this equation you are writing here. See, NiCO4 giving Ni plus 4CO, reverse of that particular one. So it's very easy to remember. First, nickel is heated in the presence of carbon monoxide vapors to form volatile complex. Then that volatile complex is decomposed to give pure form of nickel, where it decomposes at high temperature. Remember the temperature here, 330 to 350, here 450 to 470. So hope this is clear. It's called as Mond's process. Remember the name also, it's important. Next, under vapor phase refining itself, one example which we have studied is for nickel. The other example is for zirconium or titanium. Van Arkel, ARKEL, Van Arkel method for refining of zirconium or titanium. Zirconium or titanium can be refined by this particular method called as Van Arkel method. They can ask you a question of which refining method is used for the zirconium or for titanium, then it is Van Arkel method. For nickel it is Mond's process. So first what is done? Zirconium is treated with iodine vapors, iodine vapors. Again the same, first you form a volatile complex, then you decompose it. Zirconium is heated in the presence of vapors of iodine. It forms a complex zirconium iodide. What is the complex form? This is a volatile complex and the name of the complex is zirconium iodide. Zirconium iodide. So what is the first step? In the first step, zirconium is heated with iodine vapors in an evacuated vessel. Now balance the reaction. Zirconium 1, iodine 2, iodine 4. So here it is 2I2. The next reaction is exact reverse of this, but you know how to explain it. So this is the first step, formation of volatile complex. How? Zirconium is heated and evacuated vessel with iodine to form volatile complex zirconium iodide. Second step is zirconium iodide is decomposed by heating to about 1800 Kelvin. It is heated to a very high temperature of 1800 Kelvin, where zirconium iodide decomposes to again form what? Zirconium and iodine. It decomposes, breaks. Okay, first it is evaporated and then it is again further decomposed. During decomposition, what happens? Here during volatilizing, the other impurities, if it is present, especially why we go for vapor phase refining is if oxygen or nitrogen are present as impurities, they can be evaporated, they can be liberated. So this is about here what you get will be in the pure form. If suppose they ask you for titanium, it is exactly same. Replace zirconium by titanium. Ti plus 2I2 gives TiI4, titanium iodide. Then titanium iodide will be decomposed to give titanium and iodine. Is that clear? Okay. Moving on to the next important method. The last method that is mentioned in the syllabus of refining, that is chromatography. Chromatography. You have studied the principle of this as well as few important concepts of chromatography in your first year syllabus. However, so in chromatography, you know what will be done. What is done? There are different types of chromatography. It depends on the absorbing of the components in different level at different levels. That is, the principle is that the method is based on the adsorption. Adsorption, I have told you what is adsorption. Getting adsorbed. Adsorption of the various components. Adsorption of various components on the adsorbent. So the difference in the adsorption of various components on the adsorbent. So here what happens is, we take say in some cases we take, if in column chromatography, what we do, we take a solution in it. We use a phase here, which we say stationary phase, and the one moving medium is called as mobile phase. The solution is added, liquid phase or gaseous phases, solution is added, and then here what we do, we collect the moving medium. I'll tell you what it is. Moving medium, and at different areas, at different zones, you can see different substance adsorbed. It depends on the nature of the substance. So listen properly of what I am telling. See, in this we use some terms called as stationary phase, mobile phase, eluent. These are the terms which we use. Okay. Now, when we go for chromatography method is when you have very minute quantities of minute or very small quantity, minute quantities of metal. If you want to separate the if you want to refine the metal, but it is present in very minute quantity. Say in some solution it is dissolved, where you know it is very small quantity which is present. Then we subject it for chromatography. You know, chromo refers to color. Chromatography, based on the color differences, we check out, and then later it is analyzed. Here this one is an example for column chromatography. So usually what they do, you know, they take a stationary phase. Stationary phase means which is fixed. Stationary means fixed, which does not move. So they prepare a stationary phase. Usually the stationary phase which is prepared is of alumina, that is aluminium oxide, or silica. Silica gel we say. Silica gel or aluminium gel is prepared. Okay, the gel. So the gel is added to the particular column. If it is column chromatography, I mean to say, it is added. So what happens? It forms a layer here. Okay, it forms a layer. Say, it forms a layer around. Now what you do, if you know a solution in which the metal is present, isn't it? That we call as mobile phase. Mobile phase means moving medium. Moving medium, which is nothing but the solution which you have taken, from which you want to separate. Now that moving medium or the mobile phase or the solution is added from the top. When it is added, what happens? It slowly starts moving through the mobile phase. Are you getting the point? Through the stationary phase. So stationary phase means it is fixed. So through that, slowly the solution starts moving. Now it depends on the nature of the adsorbent and the substances present, components present in the solution. Different components should have ability of reacting in a different way. Now for example, you have taken aluminium gel. Say if we have many components, we have A, B, C, D components. Say we have mixture in which we have all these components. So when it is moving, at a point, say A gets adsorbed. It has a ability to adsorb soon, so it gets adsorbed here. At a point, component B gets adsorbed. At a point, again, a component, say C, gets adsorbed. Or somewhere here, the component D gets adsorbed. So at different areas, the components gets adsorbed. That is what we want to know, or we should take the difference. If the small quantity of substance is present, then the gel, that the mobile phase should, stationary phase should have the tendency to adsorb the various components. So it gets adsorbed depending on their nature. Depending on the nature of the components, it gets adsorbed. Now we separate it. We remove all the solutions. Extra solution is collected here. Slowly we move the solutions. Here, we say we are collecting it. Okay, using the knob, we are collecting the solution slowly when it is moved. And here you know all those setups, how it is made. Here a cotton plug is used so that the components does not escape and the solution is moved slowly, as well as it is filtered also. That is why a cotton plug will be used. Now the components gets adsorbed, which will be separated and analyzed. So from that also you can collect different components, or you can separate different components from the solution, metal solution. Is that clear? You know what is a stationary phase now? What is a mobile phase? We say the solution is eluted. That is a term we use. And what is eluent? Eluent means suitable solvent. We prepare a solution, isn't it? The suitable solvent is called as eluent. E-L-U-A-N-T, eluent we call it as. Hope it is clear. So chromatography is carried out for the substances, for such refining process where the metal is present in very minute quantity. And here the principle is based on the adsorption of various components on the adsorbent. And we use a stationary phase, a mobile phase. Through a stationary phase, the mobile phase is passed, and you see the various components getting adsorbed at different regions or different areas, and then it can be separated and collected. There are different types of chromatography. The different types of chromatography, if aluminium gel and silica gel is used as column, we call it as column chromatography. Okay, different types are column chromatography. Or if paper strip is used, then you call it as paper chromatography. Paper chromatography. You even have gas chromatography. There are different types of chromatography based on the type of stationary phase and mobile phase also. So here ends the process of refining. So these ways you can refine the metals and you get the ultra pure form of metals. At the end we will see some applications of metals. Applications of or uses of few important metals we'll see. Uses. So we shall start with aluminium. The uses of aluminium. So when we come to uses, you can just in a flow you can mention few uses of it which we commonly see in our day-to-day life. Aluminium, when I say, you have seen wrappers in the chocolates. Yes, that foil, aluminium foil we say for packaging of food and all, they use a foil, isn't it? So it is used as wrapper. Or say in utensils you can see vessels. Then where else can you see? It can be used for the preparing of some conducting materials. Conducting materials. Say sometimes the wires of it also can be made, and the fine dust of it. Fine dust, that is powdered aluminium, is also used in paints or lacquers. Paints, lacquers, that is the liquid solution used for polishing. This varnishes and always say, similar one it is. Fine dust is used in paints, lacquers, utensils, conducting materials, and it plays a very important role in industries. For many purposes it is used. It is also used in the extraction of chromium and manganese from its oxides. Aluminium also is used in the extraction of chromium and manganese from its oxides. So these are few very important uses of aluminium. Now let us move to the uses of copper. So as you say copper, again, what comes to your mind? There are many uses, obvious. So one use is conducting wires. You have seen wires, conducting wires for the connections and all what we use. They are usually made up of copper. So say one use is conducting wires. It is also used to make pipes. That is for the passage of water or steam. Water or steam pipes it is used. To make pipes it is used. And copper is also used in alloys. Copper is also used in alloys. A very important point to note is that it is used for the preparation of alloys. You know what is alloys? Alloys are nothing but mixture of two or more metals. So two or more metals together form alloys. Here what happens? Say compared to the initial metal, the alloys will be much tougher. It will be tougher compared to the metal from which we are preparing the alloys. So few example for alloys: brass, which is an alloy made up of copper and zinc. Alloy made up of copper and zinc. Know the composition also of what it is made up of. One is brass, which is made up of copper and zinc. Bronze is made up of copper and tin. Copper and tin. Coin age alloy. This is also a type of alloy which is made up of copper and nickel. Okay, so these are some very important uses of copper. You can note other as well. If you go checking the uses of copper, it's like you have many uses of it. So few important uses are these. We'll see the importance of or uses of other few metals. Say zinc. Which are the uses of zinc? One is it is used in galvanizing iron. Galvanizing iron means to coat iron. You know, iron gets oxidized easily. It gets rusted soon. So to prevent that, a coating of zinc is given, where zinc compared to iron, it reacts bit slowly and it is bit cheaper compared to the other metal. So the oxidation process can be slower and there won't be much loss also. That is why for galvanizing iron it is used. Zinc is also used in batteries. It's also used in batteries. Zinc. Galvanic cell it is used. It is also used in alloys. One alloy you however know, in brass, copper and zinc is present, and the other alloy of this is German silver. German silver, which is copper, zinc and nickel. It's alloy made up of copper, zinc and nickel. And it can be used in dyes, coloring agents, paints also. And most important one is zinc is used as reducing agent. Zinc is used as reducing agent. Reducing agent, you know, which helps for reduction. It also can be used as reducing agent. Now let us move on to the uses of iron. Iron, however, you know, again, you have many uses of it, out of which few are, say, in the manufacturing of stoves, railways, railway tracks, or in the preparation of wrought iron. Wrought iron, you know, which we have studied during the extraction of iron. First you get pig iron, which is converted into cast iron, and then it is converted into wrought iron. And again, the other uses is in the preparation of manufacturing of steel, in the manufacturing of toys, the manufacturing of utensils, that is vessels, or in the manufacturing of agricultural implements. This way the list goes on. Okay, even automobile parts also. In many places you can see the application or uses of copper, iron. So these were about some of the metals uses. So in this unit I'll just briefly tell you what you have studied. Initially you have studied some principal ores. You have studied important terms like minerals, ores, or say metallurgy, or what is gangue particle, what is flux, what is slag. You have studied those important terms. Principal ores you have studied of say again the same zinc, copper, iron, aluminium you have studied. And then we have studied the different steps which are involved in metallurgy, where you have studied concentration of the ores, then isolation of the metal, Then it is refining of the metal, which we have studied. So in concentration of ore, you have studied different methods like hydraulic washing, or say liquefaction, froth flotation. Then you have studied about leaching. Leaching of bauxite is really very important. Please note it and study it very well. Then you have studied some basic principles. So before subjecting the metal for reduction, we have to convert it into oxide form. So we have studied roasting and calcination there. In roasting, sulfide ores are subjected. Calcination, where volatile matters are present, there it is subjected. And then we have studied thermodynamic principles, that is using Gibbs free energy equation. We had Ellingham diagram. In Ellingham diagram, again we have studied how, looking at the Ellingham diagram, we can choose a good reducing agent for a particular reaction taking place. And the application of Ellingham diagram, we have studied extraction of iron, extraction of copper, extraction of zinc also. Then electrochemical principles of metallurgy, where you have studied extraction of aluminium, and after extraction of aluminium, some low grade ores of copper also, that extraction you have studied. Then extraction based on oxidation process also, where extraction of chlorine from brine solution is what we have studied. Then extraction of silver and gold from its respective ores also we have studied. Then today about refining of the metal, and ultimately the uses of the metal. In refining, all these methods you have studied. So my humble request is, please do concentrate. Do not ignore the videos, that however it's not important. Keep on noting the notes, and it's not just about noting the notes. Please do concentrate and study as well. Prepare thoroughly for all the concepts, and all the best. Thank you.